Software Engineering Radio episode 70, XUnit Test Patterns with Gerard Meszaros. Welcome listeners to a new episode of Software Engineering Radio. In this episode, Martin is going to talk to Gerard Meszaros about XUnit test patterns. Gerard has written a book on this topic. It's called XUnit Test Patterns. It's published in Martin Fowler's signature series with Addison Wesley. Gerard is also going to host and present a tutorial at this year's OOPSLA conference. And as you know, we've been co-producing the OOPSLA podcast together with SU Radio. And as you've heard before, this one is an extended version of the interview that we've done for the OOPSLA podcast. So if you hear Martin reference the tutorial, this of course means the tutorial he's going to give at OOPSLA, and all the stuff that he's going to talk about at OOPSLA is also relevant for the book. So have fun listening and please welcome Martin.
I would like to ask you, Gerard, to introduce yourself.
Okay, well, I'm an agile software development coach working with Clearstream Consulting in Calgary, Alberta, Canada. I've had, about 25 years experience in the software development industry, starting with writing telephone switching software, and have transitioned to sort of more traditional business IT software in the last 11 or 12 years. We started doing extreme programming and other agile methods in about 2000. And that's where we first encountered writing automated tests using XUnit. In that case, it was JUnit, but we've written them in a number of other variants of the XUnit family as well since then.
So what are you going to talk about at OOPSLA? I already mentioned a tutorial about unit testing stuff. Can you tell us a bit more about it?
Yeah, sure. My tutorial is on XUnit testing patterns. It's called XUnit Test Patterns and Smells. And the basic idea is that tests are great to have, but that you really have to be concerned about the maintainability of those tests. And if the tests are constantly breaking, or if the tests are really hard to understand, it takes a lot of energy to both write and maintain those tests. And that will discourage people from continuing to write and maintain tests. And the big issue there is that unlike production code, which you don't have a choice but to maintain, tests are optional and you can always just stop running them and just throw them away. And any investment you've made in writing all those automated tests just goes out the window. So it's really important to focus on writing good quality tests that are robust and repeatable and easy to understand. So the tutorial is about the various kinds of smells that you would encounter while maintaining test code and the patterns that you can use to avoid them.
You also wrote a book about it, is that correct?
That's correct. Last 3 years of my life have been spent writing this book. I put off writing it for a while. I was hoping someone else would write it, but after several years, no one had stepped into the void. So finally, I just bit the bullet and started, and it grew to be a lot bigger than I ever expected. I like to joke that the book is so thick because it's had twice the gestation period of an elephant.
So what motivated you to write the book and to run the tutorial?
Well, I work with a lot of different clients who are taking up agile methods. And of course, the thing that developers always jump on is the automated unit testing. I often get brought in, it's sort of two models. I either get brought in by enlightened companies to help them start the project off on the right foot, or companies that are having difficulty. They tried it by themselves and their project is in trouble. I'll get brought in to help them dig themselves out of the hole. In the latter case, what I often see is that they either don't have very many tests, or the tests that they have are consuming an inordinate amount of time to write and maintain. And we learned fairly early on in our experience of trying XP when we first started in 2000 that you can very easily dig yourself into a big hole by making some wrong decisions about how you go about automating the tests. And the tests can easily take, 70, 80, 90% of your development time, whereas they should be taking 10 or 20% of your development time. And you should be saving that all back by a reduced amount of debugging of your production code. So, having seen this recurring theme that, everywhere we went, we were looking at all these tests. They were really hard to understand. They were just begging for refactoring and cleaning up. We said, well, how can we help the community by, helping them understand how to do this right the first time rather than creating all these ugly tests and then trying to figure out a way to back away from those tests and, turn them into more maintainable tests. So we started off by one of our clients asked us if we could produce a course to present to all their staff. And we did. We created a 2-day course on the idea of how do you go about doing automated developer testing using, in that case, it was JUnit. And then the ideas of that course evolved into a more expanded form into the book and in a more condensed form into the tutorial I'm presenting at UPSLA.
Why are tests, from your point of view, so crucial? So everybody talks about JUnit, and some people use it using unit testing frameworks, and some people are not using them, and some people do test-driven development, some people do not. So what is your opinion on why are tests so crucial?
Well, the role of tests, and particularly automated unit tests in agile methods, is a means to both focus the developers on what needs to be done. So it's part of the discipline that we apply in agile methods, as opposed to document-driven methods. The discipline is about writing these huge, big documents. In agile methods, the discipline is around writing the automated tests. And before you write the code, writing the tests gives you a way to reason about what the software should do. So the tests become your requirements spec. They describe what a particular object or class should do for you, what its inputs should be, what its outputs should be in response to those inputs, whether it's stateful or stateless, and so on. And then once you've written the production code to pass those tests, the tests acting as a definition of what done looks like, then from then on, those tests act as a regression test safety net. And the key thing there is in XP, for example, the mantra is if you can delete code and no tests fail, great. You just reduce the amount of code to maintain. Mm-hmm. If you're not sure what the impact of a change will be, rather than spending hours analyzing the code and trying to figure out what would happen if you made the change, you just make the change, and the tests will tell you. The number of tests that fail tells you how big an impact that particular change has. So it leads to a much more interactive, feedback-rich, experimental style of writing code rather than a lot of, sitting in the corner, thinking, and hopefully getting everything sort of into your head. You don't have to keep as much in your head while you're working. And it makes software development a lot more enjoyable when you have tests acting as a safety net for you.
And at the end, it's about feedback, isn't it?
It's all about feedback. The tests are your feedback, because every time you save your code, compile it, and run the tests are giving you feedback. Like when I'm writing code in Eclipse, I have it set up so every time I press save, it automatically reruns all the tests. So I get feedback, every 20 seconds, minute, 5 minutes at most as I'm typing away. I know exactly what the score is. And especially when you're doing the highly incremental style of test-driven development advocated by people like Kent Beck and Dave Astles and company, they would say write one test, make the code pass that test, write the next test, etc. So you're constantly just sort of increasing the specification and writing just enough code to pass it. And that also is a form of reverse code coverage, because you never write code that you don't need in order to pass a test. One of the big gotchas that a lot of people get into is they write a whole bunch of code and then they ask, how do I unit test this? Trying to retrofit unit testability onto code that you've already written is really hard, because that means you have to think about design for testability in the abstract. And, that kind of planning ahead, even if it's 90% successful, the 10% that you didn't think about is going to get you and make it really hard to test. By writing your tests first, the tests force the software you're writing to be testable. So you're thinking about testability before you write the software. And that makes testability of the software just so much easier.
And means also that you're not coming to the situation where you think about, oh, I don't have enough time now. Let's skip the automated unit tests if you write them before, right?
Exactly, yeah. And because you have the tests, you tend to spend very little time in debuggers. If you're spending a lot of time in debuggers, that's telling you that you don't have the right unit tests in place, because the tests aren't forcing you to write the correct software, but rather you're writing a bunch of software and then you're single stepping through trying to figure out what the software is doing. Well, that's a symptom of missing unit tests.
If we talk about this kind of unit testing, it sounds to me pretty much like there are two different kinds of code. There's a production code that goes into the system, and there's the unit test code. So are those codes different, or how do you see the difference between those two kinds of code?
Yeah, they're very different. Production code, by its very nature, needs to handle a whole bunch of different scenarios. So it tends to have a lot of conditional logic in it, if statements, loops, switch statements, lots of dynamic dispatching if you're doing object-oriented, like domain-driven design. So there's an essential complexity to production code. The difference with test code is that it should be dead simple. Test code should be completely linear. Because each test should test the system in exactly one path through the system is the way to think about it, right? If the system is in a certain state, whatever the system is, an individual class, for example, and I invoke a certain method on it with a certain set of arguments, I should be able to predict ahead of time exactly what the output should be in terms of, response, return values, updated parameters, etc., and exactly what the afterward state should be. So that's a very linear sequence of statements. There shouldn't be any conditional logic in there, because the test should test one scenario. You'll have many little tests rather than one big ball of mud, as Brian Foote would call it, which is your production code.
But still, there's some similarities between those two kinds of codes, right?
Well, the similarity is that they're both written in the same language typically, and that's one of the reasons why XUnit is so popular. If you're a Java developer, you develop your tests in Java and JUnit and so on. And some of the same techniques can be used within the software to manage complexity. And some of the same refactorings of the code can be used to transform hard-to-understand code into easier-to-understand code. But beyond those similarities, in fact, the test code is quite different from the production code. This is part of the challenge for a lot of developers, is they're used to engineering highly complicated, convoluted, clever production code to solve tough problems. And they've sort of evolved the simplicity gene out of their heads, and they will naturally apply the same kind of complexity to the tests. But the problem is you're going to have typically at least as much test code as production code, and often several times as much test code as production code. And if you have to put the same kind of effort into understanding the test code as the production code, and the same kind of effort into writing the test code as the production code, you've just doubled or tripled the cost of producing your software. And no one can afford that. I mean, even with the improvement in quality that all this automated testing brings, you really cannot afford to have double or triple the cost of producing the code. It has to come out roughly the same. And that's why the test code has to be kept simple. Like, it's got to be really clean and simple, and that makes writing the code easy, and it makes understanding the code easy. And that's what a lot of these patterns are all about, is how do you structure the test code in such a way that it's easy to write test after test after test, because you've elevated the language of testing from Java or C# or whatever to something more like a domain-specific language for testing your particular application.
Does it mean that I should apply similar techniques to like I do apply to my production system, like refactoring code to make it simpler, and trying to find refactorings by finding code smells and those techniques?
Absolutely. And so just like in production code, you can either write clean code to start, or you can write messy code, whatever, first make it work and then refactor it to improve the design. And by knowing what the patterns are, you have a better chance of writing clean code to start with. But then there's a bunch of test refactorings you can use to get from messy test code to clean, simple, maintainable test code. So there, the parallel is complete. It's exactly the same issues with production code. The key difference from an agile developer's perspective, though, is that when you're refactoring production code, you have tests that protect you while you're doing the refactoring. When you're refactoring the tests, you don't have that same protection. So you have to be a little bit more careful when you're doing the refactoring of the test code to make sure that you're not refactoring your test coverage away.
Some people told me once that the tests are the safety net for refactoring production code, and vice versa, so that the production code is a safety net for refactoring the test code. Would you agree or disagree?
I agree to a certain extent. The problem with that analogy is, if I refactor my production code and the tests don't break, I was successful. If I refactor my test code and my tests don't break, that doesn't prove that my tests still work. Because while the goal of the production code is to pass all the tests, the goal of the test code is to catch defects in the production code. So the only way I can really test my tests is to inject known errors into my production code and verify that they are still caught by the tests. And the simplest way to do that is just to, if you suspect a test doesn't work, look at whatever it's testing, go into the production code and reverse an if statement, or, delete a return statement or an assignment or something like that. And if your tests don't fail, your tests aren't covering that. But that implies going in and changing the production code. Now, you're going to throw the changes away, but it's still the act of going into the production code and deliberately inserting faults into it is how you test the test code. When you're refactoring the test code, that could mean that you have to do a lot of fault injection into the production code for it to act as your safety net.
That sounds like a nice explanation. Maybe you can do the injection by some aspect-oriented techniques or whatever, but maybe just a very, very rough idea. Maybe goes beyond the topic of our talk right now.
Yeah, there is one tool I know of in JUnit called Jester, which will do that. It'll automatically go around and flip if statements and so on. And it makes one change per cycle to your production code, runs all the tests, and verifies that a test broke. And any changes that it does that don't have a broken test, it reports. The problem is, it can only, if you do more than one change at a time, you don't know which change caused the actual test to break and which changes had no effect. So it's very time consuming to run, and it's somewhat time consuming to analyze the output. I don't know a lot of people who actually go to the trouble of actually using it in that way.
So let's come back to the topic of your tutorial about the testing patterns and code smells. So I saw that you call them test smells. So can you tell us more about those test smells?
Sure. Test smells is just taking the idea of code smells that was introduced by Martin Fowler and Kent Beck in Martin's refactoring book, and applying it to the concept of test code. And there was a paper at one of the early XP conferences about, introducing the idea of test smells, and they introduced a number of these smells that are typically encountered in test code. And I've taken that idea and sort of elaborated on it and sort of built a catalog of the most common test smells and what to do about them, and use that as a way to lead people to the right patterns to apply. The test smells sort of fall into three categories. And by categories, I mean it's around how you discover the smell. So code smells are smells in your test code that a person reading or writing the test code will run into. So a smell is a symptom. It's got to pass what Martin calls the sniff test, which is it's got to come and, the smell has to come to you. It's the symptom, not the root cause. So as an example of a test code smell would be something, I'm sitting there, I'm reading some test code that someone else wrote, and I'm saying, oh my God, I cannot understand this code. This test code is really obscure. So that is an example of a code smell, obscure test. Now, there's a whole bunch of reasons why the test could be obscure, but the fact that I'm having trouble understanding it is the smell. And that's what's motivating me to think about how I could improve this test code by applying some test patterns to it. The other two categories are behavior smells and project smells. So behavior smell is what happens when you run your tests and something strange happens. Say you run the same test several times in a row and it fails the first time and passes the next few times. Well, that's an example of an unrepeatable test, or a test that gives different results when you run it. And there's several other behavior smells that are like that. And these infer problems in how your test software is written, particularly with respect to how test fixtures are being managed. The third category is project smells, and these are smells that a project manager is likely to see while observing the software development team. And, things like they'll see bugs showing up in production. Well, if you're doing proper test-driven development with lots of automated tests, you shouldn't have bugs in production. So what's the root cause of that? Well, the smell tells you that you need to go look for the root cause. Maybe it's because the developers aren't writing tests. Why? Maybe they weren't given enough time or the right training or whatever. So that's an example of a project smell.
I assume you have a list of those project smells and typical project smells, and you will describe them in more detail in the tutorial.
Yeah, there's 4 major project smells, and there's 19, I think, total smells between the code smells, the behavior smells, and the project smells, and sort of half and half. There's an equal number, roughly, of code smells and behavior smells, and then there's these 4 project smells that also come in. And in the tutorial, I introduce these smells sort of more of in a case study kind of format. So we'll run into a bunch of code smells by looking at a test, and one by one we'll go and take each of these code smells and eliminate them by applying a certain pattern to eliminate that specific smell. And so then we evolve the test from being a big, ugly, hard-to-maintain test to a much simpler test. And along the way have introduced a bunch of different test patterns. And then we do something similar in the behavior smells section. We look at what are the symptoms, that you might run into, and what are the root causes of them, and what are the patterns that you would apply to address those root causes.
And those patterns are called test patterns, right?
Yeah, that's what I call XUnit test patterns, is these standard ways of structuring your test code, how to manage fixtures, how to do assertions, how to make the software testable. Those are my design for testability patterns, things like dependency injection and dependency lookup and so on. So it's all organized around certain kinds of problems, and what are your choices for addressing them?
Mm-hmm.
For example, how do you set up a fixture? You can set it up ahead of time. You can set it up at the beginning of the test run. You can set it up in each test method or in a shared setup method. So there's 4 or 5 different ways of setting up your fixture. Each has advantages. Each has disadvantages. The reason they're patterns is because many people have used each of them. And I use the pattern form to describe them because patterns are a good way to express the knowledge, the things to take into consideration so that people can make an informed choice as opposed to just me standing there and saying, always do it this way. Well, there is no single right answer. It depends on the context in which you're operating. Sometimes you have to use shared fixtures. Shared fixtures have a major issue around them, which is the fact that you end up with a lot of the behavior smells, and you can eliminate those behavior smells by always using a fresh fixture. But you can't always afford to use a fresh fixture in various circumstances. So there's a trade-off there, and what I try and do in each of the patterns is make the trade-off explicit. What are the indications for using a particular pattern? What are the counterindications? Don't use it in this circumstance, but in this other circumstance, it might make sense. And when you are not sure you want to use this one, here's the other patterns that solve the same problem. And go take a look at those and see if any of them are more appropriate for your circumstance than this one.
So should we go in more detail into some of those examples? I know that it might get hard sometimes to explain code at the podcast, but maybe we can go through these three different kinds of smells: the code smells, the behavior smells, and the project smells, and maybe we can take a look in more detail at some of those smells and solve some problems, some more examples. So, what do you think about that?
Sure. So let's start with an example of a code smell. We already talked about obscure test. And one of the kinds of obscure test, one of the reasons for having an obscure test is if tests have conditional logic in them. My very simple rule is test methods should have no conditional logic in them. They should be absolutely linear. It should be do this, do that, do this other thing, verify the outcome. Test methods should have 4 steps, 4 parts of a test: set up the fixture, which is sort of the preconditions of the test, which includes creating the system under test, whatever class or method that you're testing. Exercise the system under test by invoking whatever method you are testing, verifying the outcome, and then cleaning up the fixture afterwards. Every test should be that simple. If you have conditional logic in your test, that's a symptom of an underlying problem. And for example, you might have conditional logic in the verification of the outcome because you're not quite sure what the input to the system was, because you don't have proper control over it. The classic example is if you're doing something that depends on time and you need to start looking at the current system time to figure out what the expected outcome should be. Well, that's a symptom that you really should, instead of trying to figure out what the outcome should be, you should be controlling the input properly by using some techniques like stubbing out the system clock in the production code so that the test can get control of the system time, or passing the time into the system under test through the method signature. So any one of those techniques can be used to avoid the test actually being several different tests that, depending on when it was run, you're actually testing different parts of the logic. In fact, what that points out is if you need to test how the system behaves at different times, like maybe AM versus PM, or on the hour versus not on the hour, or whatever, you really need separate tests for each of those to make sure that each of those scenarios is being run every time and not just happenstance depending on when you run the test. So the very fact that you have conditional logic in your test code tells you something about potentially the fact that you're either missing test conditions, or another symptom is that if the verification of the outcome is complicated because you have lists of things that you need to traverse and therefore you need loops and stuff, well, that's how you verify the outcome. But in your test method, you should very clearly state what the outcome should be and delegate the how of verifying it to utility methods, custom assertions or verification methods, or other utility methods like that build up this domain-specific library of test utility functions that you can call from your tests. And that's what makes your tests both simpler, easier to understand, and gives you a single place to modify when parts of the system under test change, so you don't have to go back and refactor hundreds of tests when you make a change in the production code.
So what are typical patterns to solve those problems?
Well, the most common one for the latter case, where you've got say you've got a loop in the part of the test where you're verifying the outcome because you have a list and you need to make sure that certain entries exist in the list and so on. Well, what you really want to do is take that loop, all that conditional logic, do an extract method on it, and turn it into a custom assertion. So there's no rule that says that only the writers of JUnit or NUnit or PyUnit or whatever are the only ones who can write assertion methods. Anyone can write assertion methods, and the simplest way to write assertion methods is to write a bunch of code that does the assertion, say, what am I really doing here? The test smell is I've got a bunch of conditional logic. I will get rid of that smell by extracting that logic from the test method and putting it into a test utility method. That could be left on the same class. So it's on your test case class, just being called from your various test methods. If you want to reuse it across many tests, you can either use a pull-up refactoring to move it onto an abstract superclass of your test case, or you can use a move method to pull it over onto a test utility class or test helper or object mother or whatever other class that you want to create to use as a little sort of library of utility methods. But your standard little atomic code refactoring is just applied with a slight twist in the context of test code.
As you mentioned, the code smells and the conditional logic, and these are symptoms of some badly designed test code maybe. I, of course, thought about situations where it's difficult to write tests for, and where you might get more complicated conditional logic in test cases, like writing tests for multi-threading code or garbage collection code or whatever. So tests that depend on how the system is executed by the underlying virtual machine or whatever. What do you think about those situations?
Well, whenever you find that it's hard to test code, it's almost always the root cause is that you're trying to test too much code at the same time. So one of the things that's important distinction is unit testing versus sort of functional testing. And in between, you can think of testing larger units, like entire components, as being, slightly different from testing individual units. So if you're doing test-driven development, you might start off saying, I'm going to write a garbage collector. What are the functional tests for my garbage collector? But then you need to break that down and say, what are the smaller pieces of my garbage collector? And then what are the individual classes and methods? And you're writing your unit tests at the individual class and method level. So when you're testing individual methods and classes, it should be pretty easy to write your unit tests. If your unit tests are trying to do things like spanning threads, that tells you that you haven't made your units small enough, and you want to separate the logic that you're testing inside the thread from the testing of the launching of the thread, from the testing of the logic that decides whether or not or when to launch the thread. So it's just a case of breaking down your tests into smaller and smaller pieces, or breaking down your system under test into smaller and smaller pieces that you can then effectively unit test. Now, to test that they're all working together properly, when you integrate all these pieces back again, then you're getting into things that are more component or functional testing. And those are more challenging to do because you have issues like, if I'm launching threads, there's latency involved in that. Now, all of a sudden, my tests have to have delays in them. And as soon as I have delays in my tests to wait long enough to give the system time to do that, I have problems with the tests running a lot slower than they would if they're just running at sort of CPU speed. So the trick is to do as much of your coverage at the unit test level where you can test the details of the logic very exhaustively, and then do just enough testing at the integration level to verify that the pieces are connected properly. And not to try and do your exhaustive testing at that level. It's the same thing when you're testing user interfaces. Testing through a user interface is notoriously difficult, both from an interfacing perspective, the fact that user interfaces tend to be asynchronous, and so the coordination between the test and the system under test, and multi-threading in the user interface and so on. So it's the same idea there. You want to break it down into little pieces, test the logic exhaustively at the individual unit level. What is the logic that decides whether or not to enable this menu item? That's a tiny little piece of logic, tiny little test. You don't want to do that at the functional test level because you're going to spend a lot of effort trying to set up the environment to cause, it to be the right circumstance in which the menu item should be either enabled or disabled, and you need several tests, and they're going through this clunky asynchronous interface, and the tests are going to take 100 times longer to run than if you test it at the unit test level. So part of your test strategy, and I talk about this a fair bit in the book, we don't have time in a 3-hour tutorial, is what kinds of tests to write for what parts of the system, and strategies for layering your system and decomposing into smaller pieces to allow each of the pieces to be tested independently, and to avoid having to test through asynchronous interfaces, whether it is user interfaces or messaging interfaces or multi-threading or whatever. So there's a whole chapter in the book about design for testability and how to structure the software to avoid a lot of these hard-to-test situations.
Ah, cool. But it's not part of the tutorial, right?
Yeah, in the tutorial, we focus on sort of what are the specific smells and how to, what patterns to apply to them. The design for testability comes up as solutions to certain problems, but we don't address the sort of the bigger picture of test automation strategy because it's too big a topic. We could do a whole 3-hour tutorial just on that one topic.
Oh yeah, I can imagine that.
So I need to expand this from a single tutorial into a whole tutorial series that I can offer.
Yeah, maybe. Maybe a complete testing tutorial series. Several days covering different topics. Okay, so let's come back to the actual tutorial. So we talked about code smells in more details. So what about behavior smells? Do you have some kind of your favorite behavior smell?
Well, let's just say that when it comes to behavior smells, it's sort of the favorite in the sense of the most notorious smells.
Mm-hmm.
Behavior smells are really insidious because they literally come and bite you in the ass. I hope I can say that on internet radio.
Why not?
It's not R-rated or anything. Whereas code smells just sort of lie there and you sort of notice them, or if you're a little bit sleepy or something, you don't really notice them. You just sort of suffer through them. Behavior smells really come, and they just come and chase you down and get you, and they bite your leg and hang on until you do something about them. So the key thing about behavior smells is you're running tests and you don't get the outputs that you expected. You expected all the tests to pass, but they're not passing. And there's a bunch of different flavors of it. The most common one I call erratic tests. And what that means is that the tests are behaving erratically. Sometimes they pass and sometimes they don't. And it all depends on the circumstance in which you run them. There's a bunch of different flavors of erratic tests. Remember, the smell is the symptom. And once you start doing some troubleshooting, you'll find the causes. So there's a bunch of different causes. There's things like unrepeatable tests, where there's something in the way the test was coded that causes it to work the first time and fail subsequently, or fail the first time and work subsequently. And it can be quite nasty to discover this pattern, because it means somehow you have to reset things. You either have to wipe out a database or close down your test runner or your development environment or something. And then when you start it again, it behaves differently. One of the symptoms is often that it works on the developer's workstation, but it fails on the integration box when it's doing a rebuild. Say you're running cruise control or something like that.
Oh yeah, I've seen this several times.
Yeah. But that same symptom that it works on your developer box and doesn't work on the cruise control box could also be a symptom of a test that is optimistic about the resources. So the resources aren't that the test depends on, it just assumes they're there. It doesn't set them up from within the test. And they're set up on the developer's box, but they were never set up on the integration box.
Mm-hmm.
Right? So there's several different root causes for that same symptom, that it works in one place or not in another place. Another example of an erratic test is one which works at certain times of the day or night or certain, like it works in 30-day months, but it doesn't work in February, or it works in normal years but not in leap years because it depends on calendar math, etc., and it's using the current system time as opposed to using a known time. Also, a lot of these issues have to be addressed by the appropriate uses of test stubs or mock objects to control the inputs of the system so that you're not dealing with random or leftover inputs, things that other tests may have modified.
Do you think that tests that depend on the state of a database, they also belong to this category?
Absolutely, because you never know what's going to be in that database. That root cause actually leads to several symptoms, several smells. One of them is the tests tend to be obscure because it's not clear in the test what's in the database. So you're using a magic number, like we're going to get customer 47. Well, what's special about customer 47, and how does that impact the expected behavior of the system under test? So you get that smell, but then you also get the smell that it works today, but tomorrow someone changed customer 47's state, and now they are effectively a different customer from the perspective of this test, and so the test fails. Or someone else wrote a new test which happens to run before your test in the test suite, which changes the state of customer 47, and therefore your test fails whenever it is run after this other test. So it runs by itself, but fails when run as a larger group. So these are all examples of erratic tests, either because they're interacting with each other, or because they're optimistic about resources, or because other tests are running at the same time, and so on. So there's a whole bunch of reasons for erratic tests. That the debugging, troubleshooting of this is so complicated that in the book I've actually got troubleshooting flowcharts for a couple of these behavior smells that sort of leads you through, asking a series of questions to help you nail down whether this is a case of an interacting test, in other words, two tests interacting with each other at runtime, or whether it's a case of resource optimism, or it's a test run war caused by some shared resources being shared globally across multiple test runners, or whatever. So it's like I said, it's quite a complicated process to sort it out. And the good news is that almost all of those tests can be avoided by using what I call a fresh fixture, which means every test sets up its own fixture every time it's run.
So this is some kind of the best choice test pattern?
Yeah, it's the fresh fixture is the pattern that one should always use if in doubt. And unfortunately, a lot of people very quickly jump to using shared fixtures, which is you set up a fixture somewhere and a whole bunch of tests use it. My feeling is that people resort to that solution too easily without understanding all the ramifications of it, and that's one of the things that gets them into trouble. And that by suitable stubbing of the fixture, they can avoid some of the issues caused with fresh fixtures. For example, if you have a database under your system, setting up a fresh fixture may take longer. Therefore, you stub out the database so that it doesn't take longer, rather than going to a shared fixture so that you don't have to set it up for each test, but that leading to all these interacting test issues. And so these are the trade-offs that I talk a lot about in the book for each of the patterns is, yeah, you could do this, and it works fine in these circumstances, but here's what to watch out for, and here are your alternatives. Instead of a shared fixture, use a fresh fixture.
Okay, so and the third kind of smell, the project smell. Do you have some kind of your favorite project smell?
So the project smells are, once again, the smells that a non-developer is likely to observe. So an agile coach, a project manager, or even the customer on the project may notice these smells. And the smells are things like bugs in production code, too much time spent debugging, and other things like that, which are sort of things that you can observe by watching people, not by actually hitting the run button on your test runner or by actually looking at test code. So let's look at the smell production bugs. What that says is that everyone's doing the best job they possibly can, but you're still finding bugs in the production system. It could be in the quality assurance, like if you've got an independent test group, they're finding bugs, or the customers are finding bugs when they put the code into production. And there's a number of different root causes of that. It could be things like the developers aren't writing all the unit tests. And then the question you have to ask is, why aren't they writing all the unit tests? Or it could be that some aspects of the system can't be tested, or that production is configured differently from the development environments, and so on. So you need to sort of understand, do the peeling the onion or asking the 5 whys to trace your way back from the symptom to the root cause that caused it. And then you address your patterns, you apply the appropriate patterns to address the root cause.
And do you have some kind of test patterns for those smells as well?
Some of those patterns, some of the root causes of the project smells are behavior smells. And some of them are code smells. So you end up with this sort of a code smell can lead to a behavior smell, which can then further lead to a project smell. A few of the project smells are completely, the root causes are completely separate from the code and behavior smells. For example, if you're finding that the production bugs are caused by the fact that developers aren't writing tests, and you ask why aren't they writing the tests, and it's because they're new to writing tests and they weren't given any training, and the project manager is telling them, no, you got to get the code done. Don't take time to learn how to do mocking or whatever. What's this mocking stuff? Focus on getting the production code working. Then that's your root cause for why you don't have tests and why your quality is suffering. It's not directly linkable to a code smell, but rather it's linkable to the project manager's behavior and the value system that they are setting for the team. And that's the root cause that needs to be addressed. Once that's out of the way, then the developers can learn how to write the tests. And in the process of doing that, they'll learn some of the test patterns to do a better job of it. But until you remove that impediment of not being allowed the time to learn it, nothing's going to happen, and you're going to have production bugs.
So I think we talked about those different kind of smells and some typical patterns. So let's wrap up this a bit. And can you give us some kind of advice for everyday work, for everyday practice, or let's say what should I do tomorrow in my project?
Well, let's assume that you're doing test-driven development, and you're open-minded, and you're prepared to assume that there are things that can be improved. And there's always something that can be improved. It's just a question of what it is. So it really comes down to, how do you go about improving your test code? One of the things that's very easy to do is, now that you have test code, do some reviews on it. Do some peer reviews. There's going to be different strengths and weaknesses amongst your development team in coding of test code, just like there is in coding of production code. And unlike manual unit testing, where it's really hard to review what kind of unit tests a person actually ran, because they were mostly doing it in a debugger, test code is an asset that you can review the quality of, and have, share the knowledge of the team with each other, and have everyone improve their test coding practices. So sitting down and spending an hour or two reviewing what tests were written and how the tests actually exercise the system, how easy they are to understand, whether there's any inherent problems in them that will lead to behavior smells and so on, is a very easy exercise to do for a team, and will help everyone's test automation skills improve.
So what do you think, are there some key factors for how to be successful with this kind of unit testing and keeping those tests alive and healthy?
What I call my recipe for success is, really, you have to learn this stuff incrementally. So that means first you have to write some tests. and pick some easy things that are easy to test. Testing legacy code is absolutely the wrong place to start, because it's the hardest stuff to test because it wasn't designed for testability. So anyone who starts off a project and says, well, before I'm going to write any new code, I'm going to retrofit unit tests onto my legacy code, is setting themselves up for failure. Focus on a new part of the system, some brand new component or something, and write it, test first, learn how to do testing there, and only once you've got a really good handle on that, back up and try and retrofit tests onto the legacy part of the system, and then only on an as-needed basis. Don't try and do it sort of big bang, let's retrofit tests on everything, only as you try and modify parts of it. So that's part one. Part two is, as you write your tests, what you want to be doing is paying attention to the test smells. So, have the list of code smells and behavior smells handy and watch for them. And just, one of these things where awareness is half the problem. Just acknowledge that these problems could exist, look for them in the code, you're more likely to find them, and that will help you understand where the opportunities for improvement are. And then, once you've seen a particular test smell, say obscure test, figure out which is the root cause of it, and that will lead you right to what are the possible solution patterns you can apply. And as you build up your skills for writing simple tests, then you can move on to more complicated scenarios and learn techniques like stubbing and mocking and the other test doubles, things like faking out the database for performance reasons and that kind of stuff. And what you will find yourself doing is slowly but surely improving the quality of the tests that you're writing. And really, you can think of this as a continuous improvement program applied specifically to your test code.
So, thank you, Gerard, very, very much for this interview and our conversation about the XUnit testing patterns. Was fun talking to you, and good luck for your tutorial.
And thank you.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.